So, like I said, before we can go backwards to get the question that actually gave us this answer, we should know the types of polynomial functions in order. What is a zero-degree polynomial function called? What's a zero-degree polynomial function called? Anyone. What is a zero-degree polynomial called?
The wow,
Yeah.
constant polynomial.
Okay, it's a constant function. What is the first degree polynomial form?
The linear.
Come again? Come again. The line was
Linear. Linear.
okay. Linear. Linear function. A second degree. A second degree is
Quadratic.
called quadratic.
Quadratic.
A third degree.
Cubic.
Cubic. A fourth degree.
Quartic.
Quartic. And a fifth degree.
Quintic.
Okay. Okay, so these are the types of polynomial functions we should know. Now, when it comes to partial fractions, it's basically breaking down a bigger fraction into bits. So what's a bigger fraction? And we're going to break it down into smaller parts. There is a golden rule for a partial fraction. So first, partial fractions should work with. Do you know what a proper fraction is? Do you know what a proper
Yes, sir.
fraction is from your junior school? What is a proper fraction? Junior school. That's from like junior school one, JHS one. Year seven.
A fraction where the bigger number is below.
Okay, so yes, basically a fraction where the denominator is bigger than the numerator. So partial fractions works with proper fractions.
Okay.
So proper fractions basically means that the degree of the denominator is bigger than the degree of the numerator. An example would be, let's say, 2x plus 8 over 3x cubed plus 4x minus 2. The degree of the numerator over here is 1 because it's a linear function, and the degree of the denominator over here is 3. Therefore, this is a proper fraction. So, partial fractions work with proper fractions. Is that okay?
Yes, sir.
Okay. Now,
Yes, sir.
once you've noticed that the fraction you are working with is a proper fraction, you need to write something called the partial fraction equivalence. Partial fraction equivalence. The partial fraction equivalence. So there is a golden rule for this one. To write a partial fraction equivalent, you always check the denominator. We first check the denominator. So check the denominator. Once you get to know the degree of the numerator is always going to be the immediate function that is lesser than the denominator. So let's write. So for for partial fractions, one, we should know that it works with proper fractions. Is that okay?
Yes, sir.
So that's the first one.
Please repeat the first one again.
So it's for partial fractions, we are looking out for proper fractions. Proper fractions. So then the second thing is that we need to write partial fraction equivalence. We need to write a partial fraction equivalence. Later, we'll talk about when the fraction is an improper fraction. We would have to do something to it to change it to a proper fraction. Then we can apply the partial fractions to it. But generally, it works with proper fractions. The next one, we write the partial fraction equivalence. To write the partial fraction equivalence, we have to check the denominator. So that's the first step to write the partial fraction equivalence. Check the denominator. I mean, check the degree of the denominator. Is everyone at that stage?
Yes, sir.
Okay. Now, after you know the degree of the denominator, the degree of the numerator, let's write the degree of the numerator is the immediate function that is lesser than the denominator. Don't worry, this is all about English. I'll do the math. So I know, like math people don't like English like that. So
The
I'm
degree
talking too
of the
much. The degree of the numerator is the immediate function that is lesser than the denominator. First check the denominator, the degree of the denominator. Then the numerator will be the immediate function that is lesser than the denominator. The immediate function that is lesser than the denominator. The
Okay.
immediate function that is lesser than the denominator. So all that English that I've said, basically this is what I mean. See that we are trying to write a partial fraction equivalent, and the denominator is x squared plus 2x minus 8. Which function is this? Which type of function is this?
Sir,
Yeah,
quadratic.
this is a quadratic function. So if you look at the order of functions, which function comes exactly before quadratic? Immediately
Linear.
before quadratic, linear. So it means that the numerator is going to be a linear function. And the general linear function is written as ax plus b. This is a general linear function. So if the denominator is quadratic, the numerator will be linear. So denominator quadratic, numerator is linear. Is that okay?
Yes, sir.
So what if
Sir.
the denominator is cubic? Yeah. Yeah, Kwame, you want
So
to
does it mean that the general rule?
Yes, that's the general rule. If the
Okay, sir.
denominator is cubic, what do you think the numerator is going to be?
Sir, it's quadratic.
Come again?
Quadratic.
Quadratic. Because
Which the
quadratic
please,
counts. Yeah.
which say you were breaking.
Okay, so I
You
was
said
asking if the denominator is cubic, what would be the numerator?
the denominator is cubic.
What will be the numerator? That would be the immediate function that comes before cubic function will be a quadratic function. You can see that after quadratic function, we go to cubic. So if you don't know the order of functions, it's going to be a little bit messy for you, but it's not going to be that messy. This is the general rule over there. So if we are looking at a denominator of, let's say, 4x raised to the power 3 plus 8x plus 2, this function is a cubic function. So it means that the numerator should be a quadratic function. Are we good?
Oh, sir.
Yeah.
Sir,
Yes.
can I do like, because I've seen 3 there on top, I should see raised to the power 2 there.
Basically, that is what I'm saying. Because this highest exponent is raised to the power 3, the exponent over there, the highest one should be raised to the power 2. So the general quadratic function is written as ax squared plus bx plus c. Is that okay?
Yes, sir.
Yes, sir.
Fafali, is that okay? Fafali, is that
Yes, sir.
okay?
Eh.
So now let's look at this one. The general one, let's say that this is 3x raised to the power 5 plus 8x plus 9. You never get a question like this, but what do you think is going to be the function at the top? Which function is this one? This is a quintic function. That's a fifth degree polynomial. There's a quintic function.
You get the one with the fourth degree, or
Yes, that is going to be the one with the fourth degree. Just like Kwame said, whatever number, the highest exponent is going to determine the highest exponent of the numerator. So if the highest exponent is 5, then the highest exponent of the numerator should be 4. The general quadratic function is written in the form ax raised to the power 4 plus bx cubed plus cx squared plus dx plus e. So this is the general quadratic function. Like I said, you will never get a question like this over there in WASI or elective maths because it's an advanced form. You may get this question when maybe you are doing math related courses at the university. I'm just teaching you the general way of doing partial fractions so that you never get yourself confused. So that you don't also memorize things that you're not supposed to memorize. Are we good?
Yes, sir.
Okay. So let's take this denominator. Let's say that the denominator is x plus 2. What do you think is going to be the numerator?
A constant function.
It's going to
So
be a
Z.
constant function. The constant function doesn't have x over there. So in this case, it's just going to be a. Are we good?
Yes, sir.
Yes, sir.
So this is a linear function. Therefore, the numerator should be a constant function. So someone can basically say that this a x raised
A
to the power 7
plus X. Uh-huh.
is that okay? But we don't x raised to the power 7 is basically 1,
Yeah.
provided x is not equal to 0. So now that we know the general way of writing partial fraction equivalent, we can
Yes, sir.
now resolve into and now look at resolving something into partial fraction. Remember the question we started with, this question. I told you that someone solved this question, and this was the answer. And the person is now trying to go back to get the original question. Maybe we want to give that question to someone else. So, okay, I solved this question overnight, and this is the answer I got. But I don't have the question with me. I have the answer. So now it's your duty to use the answer to get back the question. So that is what partial fraction is basically about. So we're going to divide this question into bits. If you look at the denominator, this is the first type of partial fraction, so type 1. We say that type 1 is denominator with linear factors. So this is denominator with linear factors. This is the first type of partial fraction. Because this one is linear and this one is linear, that's why I'm saying that is type 1. We've got 4 types of partial fractions. So we're working with the first type, okay?
Yes, sir.
Okay. So now that we know that this is x plus 5x minus 2, I can say that, okay, if I don't know anything at all, I know that because the denominator is with 2 factors, this is supposedly coming from 2 fractions, with one being x plus 5 and the other one being x minus 2. Do you agree?
Yes, sir.
So
Yes,
because
sir.
there are 2 things over there, I can say that, okay, I don't know the question all right, but I can see that, okay, this could be from the question where one of the denominators is x plus 5 and the other denominator is x minus 2. Now that we know that, remember I told you that to write the partial fraction equivalent, we are interested in the denominator. And the denominator actually tells you the type of numerator to use. So if the denominator is x plus 5, this function is a linear function. So what do you think will be on top?
It will be only maybe it is linear, so A
So this will be a constant function.
Yes, sir.
Is that okay? Linear
Yes, sir.
means it's constant. So this is
Oh,
A.
okay.
So when it comes to this side, this is also going to be a constant function. But because we've used A, this will be basically
B.
B. Is that okay?
Yes, sir.
Yes, sir.
Okay, so we'll get back to this question in some few minutes. Let's see if we can write out the partial fraction equivalent of the following example. So as you can see, this 9x plus 13, this one is not that useful in writing the partial fraction equivalent. So I'm not going to put anything at the numerator for the meantime because it doesn't do anything to the partial fraction equivalent. So let's say that there is a partial fraction between f of x over x plus 2, x minus 3, and x plus 4. What do you think the partial fraction equivalent will be?
Sir, it will be A over S plus 2
X plus 2
plus B over S minus 3
x minus 3
plus C over S plus 4.
x plus 4. Is everyone on the same level, please?
Yes, sir.
Okay. So basically, you can say that, okay, we don't know this question, but because the denominator is with 3 terms, I can basically say that, okay, this is a fraction, this is a fraction, this is a fraction. This is the only way I can get the LCM to be. x plus 2, x minus 3, and x plus 4. So good work on this one. Very, very, very good work. So let's take this one. F of x over x squared minus 3x plus.
So please I want to do it.
Okay. 2. Okay. What is the partial fraction equivalent?
So it will be a over x minus 2.
So it will be A.
A over
It
x
will be
minus
is
2.
Eh,
Okay. A over x minus 2.
yes. Plus b over x minus 1.
That is very good. But for those that you didn't see where it was coming from, first you can see that the denominator is not factored. So if you want to go further with this one, you first need to factor the denominator. So if you factor out the denominator, you get x minus 2, x minus 1. And this leaves us the format we did earlier above. Is that okay?
So say,
Yeah.
doesn't mean even if it's s raised to the power 3, we should try and factorize it.
That's why we learned how to factorize cubic functions last time.
That's it.
Are you getting me? So everything that we've learned from term 1, term 2 is going to play out throughout your math journey for the Latin math. So you have to be prepared. You don't forget anything. Okay, so the partial fraction equivalence of this is going to be a over x minus 2 plus b over x minus 1. We good?
Yes, sir.
Okay, so now that we know how to write the general partial fraction equivalence, we can now go back to solve our question. But before that, this is just another advanced one. This x squared plus 2x minus plus 19. Then this x minus 1. This would be like for a raw score. What is the partial fraction equivalence of this? So I would have said for a raw score in class, what is the partial fraction equivalence of this? Should I do it? Or would you like to give
Sir.
it a try? Yeah.
Say,
Yeah.
when you solve this quadratic equation, you get complex roots.
Good. So it means that it can't be factored.
It can be,
In this
yes.
case, the denominator still stays the same
Mhm.
as x squared plus 2x plus 19. Is that okay?
That's it.
Okay, so in this
Okay.
case, this is a quadratic function. What is going to be on top of it?
It will be ax plus b.
Good, that is a linear function. Then plus the next denominator is x minus 1. So since a has been taken, b has been taken, this will be c. So basically,
Yes,
this
sir.
is type 2 of partial fraction. You see what I just said? We've not even done type 2. But because of the explanation I gave earlier, you can do type 1, type 2, type 3 without me saying anything. So I don't want you to memorize it. Please, if you don't get what I'm saying, let me know. With that, you can be able to solve any partial fraction question, whether with my assistance or not. Let's go back to this question again. We'll do the types anyway, the type 2, type 3 anyway, so don't worry. If you didn't get this one, we'll do that one into details. So still at type 1. So we noticed that, okay, this was the question. The question was in the black, and we're trying to write the partial fraction equivalence of it. So now that we've written this in this form, we now going to try to get an identity out of this. We want to write this in terms of identities. So what we're going to do is to multiply each and every term by the LCM. In this case, LCM is x plus 5, x minus 2. So I multiply each and every term by that. Is everyone okay at this stage?
Yes, sir.
So this x plus 5, this thing basically cancels out everything over there. This x plus 5 cancels this one. And this x minus 2 cancels this one. This then gives you 9x plus 31 is identical to a multiplying x minus 2 plus b multiplying x plus 5. Are we good?
Yes, sir.
Sir, can you please repeat?
Okay, so after writing the partial fraction equivalence, we then multiply each and every term by the LCM, or I should say, We then multiply each and every term by the denominator of the bigger fraction. That is the x plus 5 x minus 2. So you can see x plus 5 x minus 2 by x plus 5 x minus 2, x plus 5 x minus 2. We get? Are we
Yes,
good?
sir.
Okay, so in
Yes,
this
sir.
case, we can see that the x plus 5 x minus 2 cancels everything over here. Then in this case, x plus 5 cancels the x plus 5, leaving you with x minus 2. And this x minus 2 cancels the x minus 2, leaving you with x minus 5. So ideally, we are left with 9x plus 31 is identical to a bracket open x minus 2 plus b bracket open x plus 5. Are we good?
Yes, sir.
I see.
Now, I don't think I should solve this question because you solved like 15 questions on identities. You don't solve
So it's that
identities.
all that led to this. Oh, I
Yes, all
see.
that's led to the identities. That's what I'm saying, that if you can solve identities, you can solve about 80% of the partial fractions. So all you need to do is to write the partial fraction equivalence, convert it to identity, then solve the identity, then you're done. That's the entire topic. So each and every one should please attempt the identities. Is Jackie back?
Yes, sir.
Okay, don't worry, I'll send
Recording.
the recording. Are you guys promoting my math file? Or you are just there like that?
Who say we are?
See, okay. So solving this identity shouldn't be that complicated. We look out for numbers that will make
Listen.
the other things go to 0. Then we take it up from there.
Sir,
Yeah.
B is equal to 7.
Okay.
And A is equal to 2.
B equal to 7. A equal to 2. It's everyone at the same level.
You see, I'm moving.
Okay.
GBP plus
It said B, A is equal to 2, B is equal to 7.
Yeah, that's what I'm putting up.
No. You straight it.
He said A is equal to 2.
A is equal to 2 and B is equal to 7.
And what am I writing?
Sir.
Okay. Are you alright?
Yes, sir.
Are you sure?
Yes, sir. No, I'm not seeing the review. That's why.
You.
So I got A to be 2, B to be 7.
Okay.
Cheers.
Okay. So we are not done. Remember, we said that this is what we started with. We're like, okay, our question is going to be in the form this. Our question is going to be in the form a over x plus 5 plus b over x minus 2. So now that we've gotten our value of a, we just put it there. So in this case, a is 2 and b is equal to 7. Is that okay?
Yes, sir.
Let's check the question we solved and see if this indeed was the question. The question we solved is 9x plus 31. Let's see if that indeed was the question. Was it the question?
Yes, sir.
Yes, sir. Yes, sir.
So you can see that we successfully changed the answer into a question. Let me put it out. So this is what we call resolving into partial fraction. We're broken down the bigger fraction into parts. Any question on this one?
No, sir.
Okay, Fafali, question.
No, sir.
Kwame, question.
Yes, sir.
Okay, good. Um, let's see if you can solve this one for me. So we've got 3x plus 5 over 2x squared minus 5x minus 3. We have to resolve this into partial fractions. We have to resolve this into partial fractions. What do you think the first thing?
So you have to make sure the bottom part you factor it.
Oh, okay, good. So let's see if we can factor this one. You can use a calculator and go backwards. So, you know how to use a calculator and go backwards, right? We learned that in school.
Yes, sir. Say x minus 3.
And x
X plus
2x minus plus 1.
2x plus 1.
So x minus 3 and 2x plus 1.
2x plus 1.
X minus 3 and 2x plus 1.
Yes.
Okay, so that's 3x plus 5. So that's what we're going to work with. You now need to write the partial fraction equivalence of this. So we can see that this is coming from a question where I think it's easy. Hello? Hello? Good afternoon. I'm doing good. Guys, please hold on.
Oh.
Hello, guys.
Okay. Copies
Can you
are
hear me?
finished.
Okay, okay. So what's the partial fraction equivalent?
It's 1. Wait, A was minus 1, alive.
I said partial
And so,
fraction equivalence. Me and your
I
side.
told you.
What's the partial fraction equivalent?
So, sir, it will be ax plus b.
Oh no. Hey.
Sorry, a over then
Yeah.
b.
as I said, we weren't supposed to solve it.
Yes.
We are supposed to solve it, but first you need to write the partial fraction equivalence.
Yeah, I wrote
Yes,
it,
sir.
but me, I was saying the answer.
So we now multiplying everything. We're going to multiply everything by
0.
x minus 3, x plus 2.
Okay, yeah.
Okay. So this step is not necessary. You are not supposed to show it if you don't want to show it. So this cancels out this. This cancels out one of them. And this cancels out this. Like I said, it's not necessary. You can move straight to this side. A over 2x plus 1 plus b over x minus 3. Then you solve the partial fraction. Solve the identity.
Say a is equal to 2.
Okay.
And then B is minus 1, or and B is minus 1.
It's 2. It's 2.
Is 2
A equal to 2 and b equal to negative.
minus 1.
It's okay. So we write our final answer. That's 3x plus 5 over 2x squared minus 5x minus 3. This is identical to a is 2, so 2 over x minus 3 plus b over, which is negative 1, over 2x plus 1. We good?
Yes, sir.
So that is type 1 of the partial fractions, and it's not anything that is super. So I think that will be the end of today's class, and we'll also meet tomorrow. It's not fine because next week we'll be preparing towards
So tomorrow is a
So what,
TV.
so what time?
Yeah, KB. What do you mean by tomorrow is starting you?
KB is going to he plays basketball on Saturday. I know.
KB.
KB
So I'll cancel my
free.
football. So I'll cancel the football.
So KB should also cancel this thing.
Yeah. KB, cancel it.
Because we have to. The reason I'm saying that is that I want us to finish the entire partial fractions. Then there is no time.
Then KB, when are you playing it? In the morning or the evening?
No, like the school, they invited the school to come and play. Like the school team.
Okay. Then that is maybe Monday. Monday is not possible. Monday. I
So Sunday.
on
So
my
Sunday.
class. Maybe we think about Sunday. But
And Sunday I'm free.
we have to finish, if not all partial fraction, half of it. And next week, I'm not really focusing on the partial fraction again because we are coming to school. So we are going to prepare towards the progressive. You know, on Monday, the first day in your class, I have a progressive with you.
And
As a matter of fact, I'll print the questions on Tuesday.
Oh.
So if you like,
Oh.
come early. If you like, don't come.
Oh.
And you know, if you don't come to, it's 0.
Oh.
Okay, so that will be that for today. I'll just keep practicing. I'll send you more questions to practice on. Then yes, that will be that. We'll do the type 2. I'll make sure we'll do type 2 and type 3 before we come to school. Then we'll do other things as well. So wait, so Chuku, you didn't bring my biscuit the other time.
Oh, sir, don't worry. Don't worry.
Worried. We are still doing online. KB,
Oh, sir, don't worry.
we are not passed because you lost me 2 biscuits. Thank you.
I will not say that. Don't worry.
Me, I owe you 2 biscuits, eh?
Yeah, like every online class now, you won't be biscuit too.
Yes, sir.
Even if it's not online class. Okay. So
Yes,
that was
sir.
all for today. I'll send you the what's the name? The questions in about 5 minutes. I don't have my time.
Yes.
Okay,
Yes,
sir.
sir.
Bye bye for now. When I send you the question, make sure you solve. I'm going to send you like about 10 to 15 questions. So solve 5 of them. Okay, solve any 5 of them. Actually, solve all, but submit any 5 of them.
Okay.
Okay, bye bye for now. And he's making a snap call.
Yes. Okay,
Okay, bye bye.
sir. All right.